Hi, everybody. So we're going to jump into the next section, section 7.2. And so in the first section, we introduced three inverse trig functions, namely the inverse tangent, the inverse sine, and the inverse cosine. Now we're going to talk about three kind of lesser known uh, uh, inverse trig functions, which you may or may not use a lot of outside of this course. Because all of these have all of these are going to just in the same way we can talk about the inverses of the secant of x, the cosecant of x, and the cotangent of x if we restrict those functions to certain intervals. So the inverse secant is just the unique angle theta such that the secant of theta is equal to x, and theta is between 0 and pi. Okay. Now this only makes sense if x is either greater than or equal to 1 or less than or equal to negative 1, because the secant can only take values in that range. Okay. Similarly, the inverse cosecant of x is the unique angle theta such that the cosecant of theta is equal to x, and theta is between negative pi over 2 and pi over 2. So this is the same range as the inverse sine function. And again, we need x to be either greater than or equal to 1 or less than or equal to negative 1. And then finally, the inverse cotangent is the unique angle such that the cotangent of theta is equal to x, and theta is strictly in between 0 and pi. And in this case, x can be any real number because the cotangent can be any real number. Okay, so we don't really have to, describe these with a unit circle. Just keep these ranges in mind. So for these first few examples, you have to think, okay, well, what would be the inverse secant of 2? Well, you're asking yourself, the secant of what? Secant of theta is equal to square root of 2. Well, that's the same thing as saying that the cosine of theta is equal to 1 over the square root of 2. Okay? Because the secant and the secant and the cosine are reciprocals, and this can also be written as the square root of 2 over 2. And you say, okay, by now, hopefully you're getting good at memorizing these values, and you'll see that this is the angle that corresponds to that is 45 degrees, or pi over 4. So the correct answer would be pi over 4, because it's certainly in this range. About the inverse cosecant of 1, well, we want the cosecant of theta to be equal to 1. If we take the reciprocals, this means the sine of theta is equal to reciprocal of 1, which is 1. And that has to be pi over 2, looks like, and pi over 2 occurs right at the end. So theta is pi over 2. About the inverse cotangent of square root 3, well, that means we want the cotangent of theta to be equal to the square root of 3, or the tangent of theta to be equal to 1 over the square root of 3. So theta is going to be, well, what is it? It looks like it's going to be pi over 6, I think, right? That's 30 degrees. Yeah. So pi over 6. For the inverse secant of negative 1, then we want secant of theta to be negative 1, which means the cosine of theta also equal to negative 1, and that's going to be pi. So this is going to be okay, and that is, let's double check, that is in this range here. And the inverse cotangent of negative 1 over square root 3, we want the cotangent of theta to be negative 1 over square root 3. So this means the tangent of theta is equal to the negative square root 3. And I believe that is good. That means theta has to be in the second quadrant. So that looks like that's going to be negative pi over 3. Negative pi over, actually, 2 pi over 3. Right. So. Okay. Okay. Keep going on here. The cosecant, the inverse cosecant of 2, we want the cosecant of theta to be 2, so we want the sine of theta to be 1/2. Okay, and looking on our unit circle, that's going to be at 30 degrees or pi over 6. If we want the cosecant of the inverse cosecant of 1/3. Now, 1/3, of course, is between -1 and 1, so this should be undefined, and we can do that as soon as if we try to do it the other way and write cosecant of theta equals 1/3. So sine of theta equals 3. Well, obviously there's no solution here, right? Because 3, the sign is always between 1 and -1. So this is undefined. Okay. The cosecant of 1.5, in this case we have the cosecant of theta equals 1.5, and this means the sine of theta, well, we can write this as 1 over 1.5, which will be equal to 2/3. And that is not in our unit circle. So we use our calculator to do this. So let's do this. We're remembering so if what we really want is theta to be the inverse sine of 2/3. Okay, that's probably what we want. Okay, and so we'll clear that, and then we'll take inverse sine of 2 divided by 3, and that's 0.730. Round up. So this will be okay. If we wanted, looks like on this next one we'll have to use our calculator again. We want the inverse cotangent of 3.82, so we want the cotangent of theta to be 3.82. So we want the tangent of theta to be 1 over 3.82. Okay, so we want theta to be the inverse tangent of 1 over 3.82. Okay, so we'll do this again. So take the inverse tangent of 1 divided by 3.82, and we get 0.256. And it's easy to check these are all in the necessary range. So the reason why we're having to do it this way, of course, is if you look at I don't think there are any calculators where they have an inverse cotangent or an inverse cosecant on it. So it's better just to break everything down and rewrite the problem in terms of inverse tangent or inverse sine or inverse cosine. So over here we have the inverse secant of 5.14. So we want the secant of theta to be 5.14. So the cosine of theta is 1 over 5.14. And so theta is going to be the inverse cosine of 1 over 5.14. And so in this case we take inverse cosine of 1 divided by 5.14. And that's 1.375. Okay. Okay, the last two are a little more conceptual here. By the way, I should say, hopefully I did this in radians mode. Okay, I don't think I converged degrees. So, obviously make sure you're in radians mode when you do these calculations on your calculator. Number 11. This is a case where it's so easy, it's hard. You're asked to find the secant of an angle whose secant is 2.7. Well, it's kind of like saying, what is the color of Bob's red car? It's got to be red, right? So the secant of the inverse secant of 2.7 is 2.7. These basically cancel out. Now, if you were to do the other direction, compose these in the other direction, the inverse secant of the secant of 9.8, the 9.8 or 9 pi over 8. Is that the answer? Well, the inverse secant has to be between 0 and pi. So unfortunately, this is bigger than pi, so we can't do that. This is not going to be the answer, but if we subtract pi from this, actually we can subtract 2 pi. We can just subtract 2 pi from this. So if we subtract, just 1 second here. Okay. Let's subtract 2 pi. And in that case, that doesn't change the value of the secant. Okay, so this is going to be the same thing as 9 minus 16. So or 9 pi over 8 minus 16 pi over 8. And let me just see here. This is let me just pause things for a moment here. Okay, let's try to work through this again. So we want to find rather than trying to find this, let's just, if we call this theta, actually let's recall that the secant of 9 pi over 8, this is equal to 1 over the cosine of 9 pi over 8. And then this is going to be equal to and why am I having a brain fart here? I guess I am. Okay, let me just pause this one more time. Okay, so I think what I get from my calculator is that this is 2.750. And I am just drawing a brain fart here right now. The problem here is the secant has a period of 2 pi, just like cosine. So you would think the problem with it 9 pi over 8 minus pi, that would be 9 minus this would turn out to be negative 7 pi over 8, but that's not in the range either. And so anyway, I just did this on my calculator. Let's not worry about number 12 right now. I'll come back to this maybe in another video. Okay, but anyway, it was almost good. So this is what happens when you do this without preparing first. So so we will. Yeah, but the main thing about this was that 9 pi over 8 is not in the range. So let's forget about this last one, and I'll let you work on some of the problems in your book, and I will see you next time.